In this video, we'll be discussing 12 Amazon Elastic Load Balancer or ELB microstacks. No single AWS service builds a production application on its own. Amazon Elastic Load Balancing is almost always the piece that sits at the front door deciding where traffic goes next. Choose the right combination and your app shrugs off traffic spikes and scales without paging anyone at 2 a.m. Choose poorly, and you get bottlenecks and outages exactly when demand is highest. This video walks through 12 microstacks built around Elastic Load Balancing, covering everything from a simple web tier to hybrid Windows file services over a direct connect link. 1. Pair ELB with EC2 and auto-scaling for resilient, self-adjusting web tiers. A fixed number of servers is always wrong for a variable amount of traffic, and pairing an application load balancer with EC2 instances under an auto-scaling group closes that gap automatically. The ELB health checks instances and routes only to ones that can serve traffic, while auto-scaling adds or removes EC2 capacity to match real demand. Together, they turn a static web tier into one that breathes with traffic, handling a launch day surge without manual intervention. It's a natural fit for web applications, content management systems, and e-commerce storefronts. One habit worth building early is tuning your auto-scaling thresholds against real traffic, not defaults. 2. Combine NLB with EC2 and EFS for low-latency shared storage workloads. Some workloads can't split cleanly across stateless servers, since every instance needs to see the same files and every millisecond of latency counts. A network load balancer, or NLB, routes raw TCP and UDP traffic with minimal overhead, while EC2 instances mount the same EFS file system so any instance can read or write files another just created. Why does this pattern share storage instead of scaling independently? It lets you scale compute horizontally while keeping one consistent view of the data, instead of building synchronization logic into the app. Gaming servers, media processing, and content systems that need every node to see the same assets lean on this. A worthwhile strategy is setting the EFS performance mode correctly up front, since switching later means recreating the file system. 3. Route ELB traffic to ECS for elastic container deployments. Running containers well means more than starting them, since traffic has to find the right healthy container even as tasks are replaced or scaled out. An application load balancer in front of Amazon ECS handles that discovery natively, registering new tasks as targets and deregistering them the moment a deployment retires them. Because it supports path and host-based routing, one load balancer can front multiple containerized services at once. That tight integration is what makes deployments genuinely hands-off, a strong fit for microservices and DevOps pipelines that deploy frequently. A good practice is setting the ELB deregistration delay and ECS health check grace period together. 4. Build a classic 3-tier stack with ELB, EC2, and RDS. Most business applications boil down to the same shape: a web layer, an application layer, and a data layer. And ELB, EC2, and RDS map onto exactly those 3 tiers. The ELB distributes requests across EC2 web and application servers, while those servers read and write to an RDS database handling replication, backups, and failover. Keeping the tiers cleanly separated makes each one independently scalable and replaceable as an application grows. It's a dependable foundation for business applications and customer-facing portals. As a rule of thumb, put RDS in multi-AZ from day one, since the cost is small next to the outage it prevents. 5. Speed up stateful apps with NLB, EC2, and ElastiCache. Hitting a database for every session lookup adds latency that compounds fast under load, and most of that data barely changes from request to request. An NLB distributes connections to the EC2 fleet with very low latency, while those instances read and write session state through ElastiCache, so repeat lookups never touch the primary data store. Why cache session data in memory? The payoff is faster response times and a database freed up for the writes and complex queries only it can do. This pattern suits high-performance applications, gaming backends, and real-time analytics. Set a sensible TTL on cached session data long enough to matter and short enough that stale state never lingers. 6. Monitor containerized microservices with ELB, ECS, RDS, and CloudWatch. Containers make deployment flexible, but that flexibility makes it harder to know what's happening across a fleet of short-lived tasks. An ELB routes traffic to containerized services on ECS, backed by RDS, while CloudWatch collects request, task, and database metrics into one place. That combined visibility lets a team catch a slow query or a failing task before it becomes an incident, rather than reconstructing it after the fact. It suits microservices where containers, data, and scaling all move independently. A useful tip is one CloudWatch dashboard pairing ELB response time with ECS task count. 7. Harden web applications with ELB EC2, Systems Manager, and Web Application Firewall. Public-facing web applications are under constant probing, and the instances behind them still need patches and consistent configuration. A web application firewall sits in front of the ELB, blocking injection and cross-site scripting before they reach an EC2 instance, while Systems Manager handles automated patching and configuration drift. What do these two services cover together? Together, they cover both halves of the security story, stopping malicious requests at the edge and keeping the fleet patched and consistent. It's especially valuable for compliance-sensitive and security-critical services handling regulated data. One tip is turning on rate-based web application firewall rules early, since they catch credential stuffing that ordinary signature rules often miss. 8. Run serverless Kubernetes at scale with NLB, EKS, Fargate, and CloudWatch. Kubernetes gives teams powerful orchestration, but managing the underlying worker nodes is its own ongoing job. Combining EKS with Fargate removes that layer entirely. An NLB distributes traffic with low latency to pods on EKS, while Fargate provisions compute on demand with no nodes to patch, and CloudWatch collects metrics and logs from the cluster and the pods. The result is enterprise-grade Kubernetes without the overhead of managing node capacity. It's well-suited to large-scale microservices deployments where operational simplicity matters as much as scalability. A strategy worth adopting is setting Fargate pod resource requests deliberately, since they directly control cost and scheduling. We have a lot more about this on systemsarchitect.io. See the full section there. Also, make sure to like the video and subscribe to the channel for more, and check the video notes for links. 9. Bridge servers and serverless with ELB, EC2, Lambda, and API gateway. Rewriting an entire application to serverless in one step is rarely realistic, but running two architectures side by side without a plan just creates confusion about where logic lives. An ELB can route requests directly to Lambda functions alongside its EC2 targets, using path-based rules, while API Gateway fronts the Lambda side with its own validation, throttling, and authorization. That flexibility makes the pattern useful for migration. New features can be built as Lambda functions and routed in immediately, while existing EC2 hosted functionality keeps running untouched. It's well suited to modernizing legacy applications where a full rewrite isn't realistic near term. A practical tip is routing by URL path, so it's obvious which functionality has already moved to Lambda. 10. Gain full observability in ECS microservices with AppMesh, X-Ray, and CloudWatch. As a microservices architecture grows, the hardest question often isn't whether a request failed, but where. Among a dozen services, it failed. An ELB routes traffic into services on ECS, while AppMesh manages retries, traffic shifting, and service discovery. X-Ray traces individual requests hop to hop, and CloudWatch aggregates logs and metrics across the mesh. How do you find which service actually failed? It turns a tangle of service-to-service calls into something you can reason about, tracing a failed request back to the exact dependency that caused it. It's built for large-scale distributed applications where the number of moving parts has outgrown what logs alone can explain. Sample X-Ray traces more aggressively on your highest traffic routes, since that's where a costly latency spike is most likely to hide. 11. Scale enterprise Kubernetes workloads with ELB, EKS, RDS, ElastiCache, and CloudWatch. Large Kubernetes deployments eventually need more than compute orchestration. They need a data layer that scales with them and a cache that keeps that data layer from becoming the bottleneck. An ELB routes traffic to pods on EKS. RDS provides durable, replicated storage. ElastiCache absorbs repeat reads, so RDS isn't hit for every request. And CloudWatch ties the platform together with metrics spanning cluster, database, and cache. Bringing all of this under one architecture gives you a platform that can absorb real production load without any single layer becoming the constraint. It's designed for large-scale web applications where performance and reliability are non-negotiable. A useful practice is setting ElastiCache eviction policies based on your actual access patterns, not the cluster's defaults. 12. Extend on-premises Windows file services to the cloud with NLB, EC2, FSX, and Direct Connect. Not every migration can start from zero. Plenty of organizations have Windows-based applications and file shares that need to keep working as they do on premises, just with cloud-scale infrastructure behind them. An NLB distributes traffic to EC2 instances with very low latency. Those instances rely on FSX for Windows File Server for managed, SMB-compatible shared storage. Direct Connect provides a private network link back on premises, and Data Sync keeps files synchronized without manual transfers. That combination means a Windows-dependent application can move to AWS without giving up the file semantics it was built around. It's the right fit for hybrid deployments that need genuine Windows file services and reliable connectivity. One tip is scheduling data sync tasks around your change patterns rather than continuous sync, since it gives predictable bandwidth and a clear audit trail. Thanks for checking out this video. Hope you liked it and subscribe to the channel. Find a lot more articles and guides both on systemsarchitect.io and codeguides.io. Again, that's systemsarchitect.io and codeguides.io.